Welcome back everyone, Patrick here, moving on to another question dealing with right triangles. So what we have to do is for each of these triangles here, we have to find the length of x. So starting with this first right angle triangle, we have this side length here 4, we have this angle 22 degrees, and then we have the x right here. Now, first thing I like to do with these kinds of problems is label the sides as either being the opposite, the adjacent, or the hypotenuse. And I always like to label the hypotenuse first because it's always going to be the opposite of the 90-degree angle, right? So the opposite side to the 90-degree angle is actually what we're solving for in this triangle. It's the x value. It's not always going to be the hypotenuse we'll be solving for. So for example here, notice we have the 90-degree angle. Well, the hypotenuse is this 10. Okay, and this x here is another length that we're solving for, but in this case it's going to be the hypotenuse. So I always like to label the hypotenuse first opposite to the 90-degree, right? So here that's going to be the hypotenuse. Over here this length is going to be the hypotenuse. And then from there all that's left to label is the opposite or the adjacent side, and that's going to depend on the angle that you are referencing. So notice that if we're referencing this angle here of 22 degrees, well, the side that's attached to it, that's not the hypotenuse, the other side, that's always going to be the adjacent side. And then that means that this side here is the opposite side. But notice the opposite side, we're not given the length, we're given the length of the adjacent side, and we're solving for the hypotenuse if we're using this angle here. Now, if we were using this angle over here, let's just label it theta. We could actually solve for that angle. It would be what, 68 degrees, right? Because 68 plus 22 would give us 90. So if we were using this angle as the reference angle, the hypotenuse would still be this side here, opposite to 90, but then this side here would be the adjacent, this would be the opposite, if we were using that angle as the reference. But we're using this 22 degrees as the reference. Okay, so this is the adjacent side to it, that's the opposite side to it. Now, let me bring back that SOHCAHTOA saying. And of these three ratios, which one uses the adjacent side and the hypotenuse? The adjacent and the hypotenuse is used for the cos ratio. So the way we would set this up is we would go cos of the angle 22. It's always going to be cosine or tan of an angle, right? That's what's going to go in the brackets here always. That's attached to the ratio. Is going to equal the adjacent over the hypotenuse. So let's actually write that. Adjacent over hypotenuse. So in this particular case, the adjacent side is the 4, and then the hypotenuse is what we're solving for. It's going to be the x right there. So we have our ratio set up. Cos 22 equals 4 over x. And so from here, we could put this over 1 and we can cross multiply. So 4 times 1 would give us 4. And then we would have x times cos of 22, like that. And then if we want to isolate for this x, we would divide both sides by what's attached to the x, which would be the cos 22. Right, so continuing this here, basically x, those would cancel out, x would be isolated, it's going to equal 4 over cos of 22. And when you do that calculation, you'd end up with 4.31. So that would be the answer over here. The length of this hypotenuse would be 4.31, and we got it with the cos ratio. Moving on to the next triangle. So here we already labeled the hypotenuse opposite to the 90-degree angle. That's always the first side I label. Now here, if we're working with this angle as the reference angle, well, this x here, notice that that's the opposite side, right? Because the side that's attached to the angle, that's other than the hypotenuse, this is the adjacent side. Well, all that's left with is the opposite side. Okay, and so notice that if we're using this angle, we'd be using the opposite side and the hypotenuse, which of the ratios use the opposite and the hypotenuse? Opposite, hypotenuse. So it's the sine ratio. So we would go sine of 34 equals the opposite over the hypotenuse. And so sine of 34, well, the opposite is actually what we're solving for. We're solving for the opposite side in this case, and then the hypotenuse is 10, like this. So we can go put this over 1. 1 times x is x, so x is actually already isolated in this case, and then we'll have 10 times sine of 34, and when you multiply those, you'd end up with 5.59, like that. Right, so that would be the answer for part 2. This x value here would be 5.59 units. Moving on to number 3 over here. So let's label these sides. Again, let's start with the hypotenuse. We got the 90-degree angle here. Notice how sometimes these triangles, they can be rotated or put in different positions. But again, same thing applies. We got the 90-degree angle here, the opposite side to it, which is this side. That means this is going to be the hypotenuse, right? Sometimes students, they'll make the mistake when, especially when a triangle is in this kind of different format, when it's rotated a bit, they'll look at this angle and they'll go, oh, well, this side is the adjacent side to it, but it's not. This is the hypotenuse. This here is the adjacent side, right? The hypotenuse is always opposite to the 90-degree angle. So that's why I always label that first, because the opposite and adjacent are subjective. They depend on which angle you're looking at, but the hypotenuse never depends on what angle you have or what angle you're given. It's always opposite to the 90-degree angle. So that's always what I label first. Now if we're dealing with this over here with this angle, well, notice that this side here is going to be the adjacent, the side other than the hypotenuse that's attached to the angle, and so that means that this side here is the opposite side, like that. And so notice in this particular case, we're working with this angle, we're working with the adjacent side because we're given that as 6, and then we're solving for the opposite side, which is the x value. So we're working with the opposite and the adjacent side. Which of these ratios works with the opposite and adjacent? The tan ratio. So we would go tan of 50. Now the tan ratio is always what? Opposite over adjacent. So we would go tan of 50 is equal to the opposite side, which is x, over the adjacent side, which is 6, like that. So put this over 1, cross multiply, 1 times x is x, and then we'll have 6 times tan of 50. And when you multiply those, you'd end up with this 7.15 right there. All right, so that's the answer for number 3. That is this side here at 7.15 units. Now moving on to triangle 4. So we got this. Now again, first thing, we got the 90-degree angle. Opposite side to it is always going to be the hypotenuse, like that. Now this is the angle that we're working with, the reference angle. So the other side that's attached to it is the adjacent side, like that. We got the hypotenuse attached to it. We also have the adjacent side attached to it. So that leaves this 11 being the opposite side. So notice what we're working with is the angle, the opposite side, which we're given as 11, and then we're solving for the hypotenuse. Which ratio deals with the opposite and the hypotenuse? The sine ratio. So we can go sine of 70 equals the opposite over the hypotenuse. So we'll have sine of 70 equals, what's the opposite side? It's the 11. And then the hypotenuse is the x. That's what we're solving for. Cross multiply. X times sine 70, right there, is equal to 1 times 11, which is that. Divide both sides by sine 70. Right, these cancel out. So we'll end up with 11 over sine 70. That's what x is going to be. And then when you put in your calculator, it will be approximately 11.71, like that. Right, 11 divided by sine 70 is 11.71. So that would end up being this length over here for x, like that. Okay, and then finally we got number 5, the fifth triangle. So again, 90 degrees, opposite side to the 90 degree hypotenuse. If we're looking at this side as the reference, what's the other side that's attached to it? This side, so that's the adjacent, meaning that this is the opposite right there. So notice that we're given the opposite side and we're solving for the adjacent side. So which ratio deals with the opposite and the adjacent? 10 right there. So we go 10 is 26 is equal to the opposite over adjacent. That's what the tan ratio is always going to be. So we'll have tan of 26 equals the opposite side, which is 7, over the adjacent side, which is x in this case. Okay, and so we would cross multiply here. This is over 1, sorry, and then 1 times 7 is 7. So x, we would divide both sides by this bracket to get the x by itself. So x is basically going to be 7 over 10 of 26. And when you do that calculation, you'd end up with 14.35, like that. Right, so that would be the answer to this x value. Okay, and as I mentioned before, different ways you could actually solve this too. In this case, we're given these angles here, but you could always perhaps get this angle. So 90 minus 26 would give us what? 64. And then what if we use the 64 over here instead to solve for this x? Well, if we use this 64 as the reference angle, then this would be the adjacent side now. And then this here, the x that we're solving for, would be the opposite. Right? The hypotenuse stays the same. It doesn't matter which angle we're referencing. So we would set this up as tan of 64 equals the opposite, x, over the adjacent, 7, cross multiply, 1 times x is that, 7 times tan of 64, and when you do that calculation, you'd still end up with 14.35, like that. Right? So whichever way you do it, you should get that same side length. But there's no reason for us to solve for this other angle. It's just extra work. Also, it increases the chance of making a mistake. Use whatever angles are given. If there's only one angle given, label the sides correctly in reference to that angle, and then use the correct ratio in order to solve for your length.